What if one of the strangest messages ever detected from the universe wasn't sent by aliens at all, but by one of the most extreme objects in existence? Imagine scientists pointing some of the world's most powerful radio telescopes toward the night sky when, without warning, they detect a powerful burst of radio waves that traveled across billions of light years before reaching Earth. It lasts for only a fraction of a second, then it's gone. Yet in that tiny moment, it releases an incredible amount of energy. For years, these could be signs of intelligent life. Others believe they came from violent cosmic events unlike anything ever seen before. Today, thanks to years of careful research, scientists have uncovered remarkable clues. But the mystery is far from over. This story is not science fiction. It is based on one of the most fascinating astronomical discoveries of the modern era: fast radio bursts. It's often called FRBs. These are real, extremely powerful bursts of radio energy that arrive from deep space. The first confirmed FRB was discovered in data collected in 2001 by the Parkes Radio Telescope in Australia and was announced in 2007. At first, many scientists questioned whether the signal was even real. Some believed it could have been interference from equipment on Earth. But as more observatories began detecting similar bursts, it became clear that something extraordinary was happening across the universe. The challenge was that these signals were unbelievably short. Most lasted only a few thousandths of a second. By the time astronomers noticed them, they had already disappeared. Unlike planets or stars that can be observed for years, these bursts left behind almost no clues. Scientists had only tiny pieces of evidence to study. Every new detection raised more questions than answers. Then something unexpected happened. As radio telescopes became more advanced, researchers started finding more FRBs than ever before. Observatories like the Canadian Hydrogen Intensity Mapping Experiment, known as CHIME, transformed the search. Instead of detecting only a handful of mysterious signals, scientists suddenly found hundreds. Some appeared only once and were never seen again. Others repeated over weeks, months, or even years. That single discovery changed the entire investigation. If some signals repeated, then whatever created them had to survive after each burst. This ruled out several earlier theories and opened the door to entirely new possibilities. Through space, scientists also gained valuable information about the invisible gas floating between galaxies. In other words, these mysterious signals were becoming powerful tools for understanding the universe itself. But the biggest breakthrough was still waiting. In 2020, astronomers detected a fast radio burst coming from a magnetar inside our own Milky Way galaxy. Magnetars are rare neutron stars with magnetic fields so powerful they can unleash enormous explosions of energy. For the first time, scientists had strong evidence that at least some FRBs could be produced by these extraordinary objects. It was a major step forward, but it did not solve every mystery. Many bursts observed across the universe were far more energetic than the one detected in our galaxy, suggesting there could be more than one way to create these incredible signals. The deeper researchers looked, the stranger the story became. Some repeating bursts followed patterns that no one expected. Others appeared to originate from surprisingly old galaxies instead of young regions filled with newly formed stars. Every answer seemed to create two new questions. And with each passing year, more sensitive telescopes continued discovering signals that challenged existing theories. Scientists now believe that fast radio bursts are among the most important astronomical mysteries of our time. They are not evidence of alien civilizations, and no confirmed observation has shown that they are artificial. Instead, they reveal just how energetic and unpredictable the universe can be. They also remind us that even with all of humanity's technology, we have explored only a tiny fraction of the cosmos. And as the next mysterious signal races across billions of light years toward Earth, one question remains unanswered. What else is hiding in the darkness, waiting for us to finally listen? For years, scientists believed that if they collected enough data, the mystery of fast radio bursts would eventually disappear. But the opposite happened. Every new observation revealed something even more confusing. Instead of one clear explanation, astronomers were faced with a growing list of strange behaviors that no single theory could fully explain. The biggest surprise came when researchers realized that not all fast radio bursts behaved the same way. Many of them flashed only once. They appeared without warning and were never detected again. Others, repeated over and over, sometimes weeks apart, sometimes months apart, and in a few cases following patterns that seemed almost predictable. This immediately divided scientists into two camps. Were all FRBs created by the same type of object? Or were astronomers actually looking at several completely different cosmic events that only appeared similar? To answer that question, researchers needed something they had struggled to obtain from the very beginning: an exact location. Finding the source of a burst lasting only a fraction of a second is incredibly difficult. Imagine trying to locate the exact window in a city where someone briefly turned on a flashlight for less than the blink of an eye. That was the challenge facing astronomers. But thanks to powerful arrays, such as the Very Large Array in the United States and other advanced radio observatories, scientists finally began tracing some FRBs back to their home galaxies. What they found changed the investigation. Some bursts came from young, active galaxies where stars were still forming at a rapid pace. That supported the idea that Magnetars, young neutron stars with unbelievably strong magnetic fields, could be responsible. Magnetars are created after massive stars explode as supernovas. They are capable of producing violent outbursts of energy. But then another discovery complicated everything. Other fast radio bursts were traced to much older galaxies where very few new stars were being born. These environments were not where scientists expected to find young magnetars. Suddenly, the simplest explanation no longer fit every observation. The truth was becoming even more complicated. Researchers proposed several possibilities. Some suggested that older magnetars might remain active much longer than previously believed. Others wondered whether collisions between neutron stars, black holes, or even white dwarfs could produce similar radio bursts under certain conditions. Hypotheses explained part of the evidence, but none explained all of it. Meanwhile, new telescopes continued collecting astonishing amounts of data. The Chime Observatory in Canada became one of the most important tools in the search. Designed to scan huge sections of the sky every day, it detected hundreds of fast radio bursts, dramatically increasing the number of known events. Patterns that had been invisible before slowly started to emerge. Then, investigators uncovered something nobody expected. Some repeating FRBs appeared to switch on and off in regular cycles. One famous repeating source showed activity for several days, before falling silent for weeks, only to become active again later. Scientists debated whether this rhythm was caused by the object spinning, orbiting another star, or interacting with its surrounding environment. Every possibility pointed toward extreme conditions unlike anything found in our own solar system. At the same time, researchers carefully ruled out more ordinary explanations. They checked for interference from satellites, aircraft, communication systems, and equipment on Earth. Independent observatories on different continents detected the same kinds of bursts, confirming that these signals truly originated from deep space. Even so, public imagination often raced ahead of the evidence. Whenever a particularly unusual FRB made headlines, speculation about alien civilizations quickly spread across social media. Scientists understood why people were fascinated. After all, a mysterious radio signal from the depths of space sounds like the beginning of a science fiction movie. But the evidence told a different story. Despite years of careful study, no confirmed fast radio burst has shown signs of carrying a message, repeating in a way that suggests communication, or displaying characteristics that require an artificial origin. The signals are extraordinary, but every confirmed observation points toward natural astrophysical processes occurring under incredibly extreme conditions. Still, that did not make the mystery any less exciting. In many ways, the universe itself is proving to be far stranger than fiction. Every new burst carries information about the matter it passed through during its journey across billions of light years. Hidden within those tiny flashes are clues about invisible gas between galaxies, powerful magnetic fields, and the evolution of the cosmos itself. Scientists were no longer studying mysterious radio signals alone. They were using them as cosmic probes, allowing humanity to explore regions of the universe that had remained almost completely invisible. But the biggest breakthrough was still ahead. One remarkable discovery would provide the strongest evidence yet for where at least some of these mysterious signals come from, and at the same time, raise an entirely new set of questions that no one had expected. Everything changed in April 2020. For the first time in history, scientists detected a fast radio burst coming from inside our own Milky Way galaxy. Until then, every confirmed FRB had appeared to come from galaxies millions or even billions of light years away. They were so distant that astronomers could only study them from afar. But this new signal was different. It came from a known object, only about 30,000 light-years from Earth, a magnetar, called SGR 1935, plus 2,154. The discovery immediately captured the attention of astronomers around the world. Several observatories, including CHIME in Canada and the STARE, to experiment in the United States, detected the powerful burst almost simultaneously. Because multiple instruments recorded the event, scientists could confidently rule out equipment errors or local interference. This was a real cosmic signal. It matched many of the characteristics seen in the mysterious fast radio bursts arriving from distant galaxies. For years, magnetars had been one of the leading suspects. Now, researchers finally had direct evidence that these extraordinary objects could produce FRB-like signals. Magnetars are the collapsed cores of massive stars that exploded as supernovas. Although they are only about 20 kilometers or 12 miles across, they contain more mass than our Sun. Their magnetic fields are so powerful that they are considered the strongest known magnets in the universe. When stress builds inside a magnetar's crust, it can crack in what scientists call a starquake. That sudden movement releases an enormous amount of energy, sending powerful bursts of X-rays, gamma rays, and sometimes radio waves racing into space. The 2020 event strongly suggested that at least some fast radio bursts are born during these violent explosions. But that wasn't the biggest surprise. The burst from SGR 1935 plus 2,154 was much weaker than many FRBs detected from distant galaxies. If it had occurred much farther away, many telescopes might not have seen it at all. That raised an important question. Were the brightest fast radio bursts simply stronger versions of the same event, or were scientists still missing another piece of the puzzle? The mystery deepened as researchers compared hundreds of observations. Some FRBs repeated many times. Others never returned. Some came from regions packed with young stars, while others originated in older galaxies where few new stars were forming. It became increasingly clear that magnetars explained many observations, but probably not every single one. Then another remarkable discovery pushed the investigation even further. Using advanced radio telescopes, astronomers began measuring the environments around several repeating FRBs with incredible precision. They found evidence that some signals were passing through extremely powerful magnetic fields before reaching Earth. This matched what scientists would expect if the bursts were being produced near highly energetic objects such as magnetars. At the same time, every signal told another story. As radio waves travel across the universe, they pass through thin clouds of gas spread between galaxies. Lower frequency waves slow down slightly more than higher frequency waves. By measuring this tiny delay, scientists can estimate how much matter the signal encountered during its journey. This process has turned fast radio bursts into one of astronomy's newest and most valuable tools. In fact, FRBs are helping researchers solve one of cosmology's biggest mysteries: the location of the universe's missing ordinary matter. For decades, astronomers knew that a large portion of normal matter predicted by cosmological models could not be directly observed. Studies of fast radio bursts have shown that much of this matter is spread as extremely thin gas between galaxies, almost invisible to other methods of observation. What started as a strange mystery had become an unexpected scientific breakthrough. Instead of simply asking where these signals came from, researchers were now using them to map the invisible structure of the cosmos itself. Every newly detected burst acted like a flashlight shining through billions of light-years of space, revealing details that had remained hidden since the universe was young. Yet the investigation was far from over. The most sensitive observatories ever built, including the Square Kilometer Array, currently under construction, and China's 500-meter aperture spherical telescope, fast promised to detect thousands more fast radio bursts in the coming years. And with each new detection, scientists hope to identify more sources, test competing theories, and finally understand why these mysterious signals appear in so many different forms. But one final question still remains. If magnetars explain many fast radio bursts, what explains the rest? Are there other extreme cosmic events capable of producing these incredible flashes? Or is the universe preparing to reveal another secret that no one has even imagined yet? That final mystery would shape the next chapter of one of astronomy's greatest investigations. As scientists pieced together more evidence, they began to realize that the mystery of fast radio bursts was becoming much bigger than simply discovering where they came from. Every new signal was doing something extraordinary. It was carrying information about the universe itself, instead of being just another unexplained phenomenon. FRBs were turning into one of the most powerful tools ever created for studying deep space. The breakthrough came from a simple but remarkable fact. A fast radio burst does not travel through empty space. On its journey to Earth, it passes through clouds of gas, magnetic fields, entire galaxies, and the vast stretches of nearly invisible matter that fill the universe. Every one of those regions leaves a tiny fingerprint on the radio waves. By carefully measuring those fingerprints, scientists can reconstruct parts of the signal's incredible journey that changed everything. For decades, astronomers had been searching for the universe's missing baryons. These are the ordinary particles, protons, and neutrons that make up stars, planets, and people. Theoretical models showed that this matter should exist, yet nearly half of it could not be directly